Hello everyone, I am Shweta Jagtap. I will be talking about simulation analysis in this video. Simulation analysis is applied in highly complex situation when even mathematical modeling is also difficult. Generally, we apply this when future is quite uncertain and we don't know what will happen. Only we know is the probability of occurrence of some event. So, we use the information which is available in the form of probability to find out answer to the question. Moving on to the first slide, it talks about sensitivity analysis. Sensitivity analysis indicates the sensitivity of a criterion of merit, that is NPV, IRR, or any other, to variation in basic factors. Though useful, such information may not be adequate for decision making. For example, in sensitivity analysis, we have seen that if we decrease sales, then our NPV would also decrease. But what is the probability of that decreasing NPV? So, to calculate those probability, we use simulation tools. The decision maker would also like to know the livelihood of such occurrence. This information can be generated by simulation analysis, which may be used for developing the probability profile of a cert criteria of merit by randomly combining values of variable that have a bearing on the chosen criteria. There is a particular procedure in conducting this analysis. The first step is we need to model the project, which means the NPV is related to different parameters. Right parameters means those variables which are under the control of decision making, and there are some exogenous variables which cannot be controlled. In simple words, we have to know how the NPV is related to the parameters. The second step is to specify the value of parameters and probability exogenous variables. The probability of these can be found from past data, then in simulation. We generally come up with random numbers which are available in books of statistics, in books of financial accounting, and so on. Random numbers are used because the input data are mostly random in nature. So, to solve a problem, we have to use random numbers. Third step is to select a value random from probability distribution of exogenous variables. The next step is to determine the NPV. We can have 10, 15 or 10,000 runs. Manually, if you do this type of question, it is very difficult, but using computer, it's easy. And then the end you can plot frequency distribution of NPV. The distribution of NPV can take different shapes. It may take normal or triangular distribution shape or step distribution shape. So, it all depends on the probability of exogenous variable and the random numbers. And when you decide to do 10 runs, you need 20 random numbers. Likewise, now we will be doing a problem, a illustration problem in which we will be doing 10 runs. Hence, we'll be taking 20 random numbers. And the formula used for calculation on NPV is given on the slide. That is annual cash flow divided by 1 plus risk-free return to the power of t minus initial investment. For this problem, the risk-free return will be 10%, initial investment will be 13,000, the exogenous variable having following probability distribution. As you can see, the annual cash flow table, there are 7 different values and probability given, which means for the first value, that is 1000, the probability is 0.02, which means that the occurrence can be twice out of 100. The same goes to the following cash flows. 1500 has 0.03 probability, 2000 has 0.15 probability, and so on. So, the random number chosen are 53, 66, 30, 19, 31, 81, 38, 48, 90, and 58. These are 10 random numbers for annual cash flow. The next is the table of life cycle. There are year and probability given, 7 years and 7 probabilities with 10 random numbers. As I said, we will be running 10 runs, hence we will need 20 random numbers, 10 for life cycle and 10 for annual cash flow. The first step in solving this problem is you have to calculate the cumulative probability and give them tag number. As you can see on the screen, the value is 1000, the probability is 0.02. To calculate the cumulative probability, the first value cumulative probability will remain same, but when it comes to the second value, that is 1500, you will have to add 0.03 and 0.02, that is the previous probability, and write the cumulative probability, and the same goes on. And the next column is tag number. As I already said, the probability of occurrence of 1000 is 0.02, which means it can occur only twice. So the tag number will be 00 to 01. For second value, the cumulative probability is 0.05. So the tag number will be continuous to the first tag number, that is, we ended the first tag number on 01. So we will start from 02 and it will be till 04, as the cumulative probability is 0.05. The same will go on to the last value also, that is 4000, as the probability is 1.0. So the tag number will be 85 to 99. This was the calculation of cumulative probability and tag number for the annual cash flow. We will have to do the same for the life cycle. As you can see, there is same procedure followed and the tag number are being assigned. The final step is calculation of NPV. To calculate the NPV, we will use the random numbers and the value. Here in this table, as you can see, the first column is of annual cash flow and it has sub column, that is number of runs, random numbers and value. Number of runs is, as I said, we will run 10 runs. So it has 1 to 10 numbers, and random numbers which were assigned in the previous slides. Those numbers will be written down. And how do you determine the value? Here you have to see where the random number lies in between the tag numbers. The first 53 random numbers lies in the value of 3000, as that is the tag number is 35 to 64. Hence, you have to do the same thing to the annual cash flow table as well as life cycle. And by using the formula of NPV, we will calculate the NPV and write it down in the last column. So, let me summarize what we did in this particular method in simulation analysis. As I said, it is to be used in a situation where it is highly complex. So, you have got controllable variables, some of them are uncontrollable variables. For uncontrollable, you have their probability distribution. Use probability distributions to come up with tag numbers, and you will have to use random numbers. And random numbers we will decide. What would be the right answer if you change random numbers? Your NPV will also change. So, you can solve the same problem using different random numbers, and for life cycle as well as annual cash flow. Thank you everyone.